All right, so this is your 2.1 notes. So example 1, plot each of the following points on the axis below. Identify which quadrant each point is in. So recall points are labeled x comma y. So the first value is where you go on the x-axis. Second value is where you go on the y-axis. As far as your quadrant numbers, this is quadrant 1 here, and then it goes counterclockwise. Quadrant 2, down below, this is quadrant 3, and finally quadrant 4. So plotting points, our first point 1 comma 6, right 1 on the x-axis, up 6 on the y-axis. So remember, this is your x-axis, this is your y-axis. So 1 comma 6 is going to be here. So that point is in quadrant 1. Second point, negative 2 comma 3, left 2 and up 3. So we're going to be here. That one is in quadrant 2. Third point is 4, negative 5. So right 4 and then down 5. So right 4, down 5 puts us here in quadrant 4. And finally, last point, negative 3, negative 6. So going left 3 and then down 6. And that is in quadrant 3. 3. Okay. All right, your second one. Determine whether each of the following pairs is a solution of the given equation 4y plus 3x equals 18. So to determine whether something is or is not the solution to an equation, you simply plug in the given values for the appropriate variable and then do the algebra to see if the equation turns out true or if it turns out false. So our equation is 4y plus 3x equals 18. So 4y plus 3x equals 18. And we're being asked to check the point 2, 3. So that means 2 is going in for x and 3 is going in for y. So we're going to get 4 times 3 plus 3 times 2 equals 18. And then we just do the algebra to see what happens. So 4 times 3 is 12. 3 times 2 is 6. And 12 plus 6 is 18. So we look at our last step, 18 equals 18. This is a true statement. So therefore, this is a solution. So we would just simply say the point 2 comma 3 is a solution, if I could spell. Solution. It's an L. All right. Second one, still the same equation, just checking a different point. So now we're checking 1 comma 5. So I'm still going to write my equation down, even though I can see it. So now we're replacing y with 5 and x with 1. So 4 times 5 is 20. 3 times 1 is 3. And 20 plus 3 is 23. So we're left with the end result, 23 equals 18, which clearly does not equal each other. So this is a false statement. Therefore, this is not a solution. So we would say the point 1 comma 5 is not a solution. All right. Next one. All right, graphing linear equations. So right now we haven't gone over any characteristics of any type of function. So really the only strategy we have for graphing is to pick points and plug them in. So what we're going to be doing here is we are trying to graph the linear equation y equals 3x. So I need to pick an x value. You can pick anything you want and plug it in to see what y would be. Now make sure you look at your grid. I don't really want to choose x to be like 15. Because 15 is way down here on my x-axis. That's way off the grid. I want to make sure I stay on my grid. So I like to stay around 0. So also when you plug in, don't torture yourself and pick horrible numbers like fractions. Pick nice, easy pretty values. So I'm going to choose, I always start with 0. So our equation is y equals 3x. Just going to write it down. And I'm starting at 0 for x. So what I'm trying to do is figure out what y goes with the x value 0. So to do that, we just plug in 0 for x and then solve. 3 times 0 is 0. So that tells us when x is 0, y is 0. So we're going to get the coordinate 0, 0. So my graph, I'm going to go plot 0, 0, which is right at the origin. And now I'm going to pick another point. It takes 2 points to make a straight line. You could go with 1, 2, -1, -2 is whatever you'd like. I don't know. Let's go with 2 this time. Let's try 2. Again, just stick kind of close in around the origin. I said 2 and I wrote 0. So y equals 3 times 2. 3 times 2 is 6. So this coordinate would be 2, 6. So right 2 of 6, we're here. It only takes 2 points to make a straight line. So then I'm going to draw my line. Kind of missed it a little bit, but that's all right. I'm going to get my arrow on there. And my arrow on here. So there's my graph. Next one. Sketch the graph of the linear equation x plus 2y equals 6. So doing the exact same thing we just did, set up a little bit differently because y is not by itself. Still the same process, pick some x values. You're just going to have to do a little more of the algebra in order to figure out what the y value is. So x plus 2y equals 6. All right, I like my 0, so I'm going to start at 0 again. So we're replacing our x with 0. 0's, there's no reason for it to be there. It's just going to be the 2y. We're going to divide both sides by 2. And 6 divided by 2 is 3. So we're going to get the coordinate 0, 3. So going straight up the y-axis to 3. All right, and then I'm going to pick another point. So I'm going to do a little separation here. All right, I don't know, let's try 1. Maybe. Nah. Let's go with 2. So we're going to get 2 plus 2y equals 6. No reason for those parentheses, so I'm going to drop them now that I know nothing needs to be multiplied by it. I'm going to move my 2 to the other side by subtracting it. 6 minus 2 is 4. I'm going to divide the 2 off. 4 divided by 2 is 2. So at 2, we get a y value 2, so our coordinate is 2, 2. Lots of 2's. So 2, 2 is here. So those two are a little closer together than our other ones. It still does only take 2 points to make a straight line. So if you're confident, you can go ahead and get that line sketched in. If you want, you could go ahead and bring in another point just to make sure you do have it in the right place. And get my arrows. Maybe we're not in arrow mode. 1, 2. All right. All right, example 5. Sketch the graph of the equation y equals x squared minus 1. So we've kind of changed gears here a little bit. So one of these equations, the second type of equation you're going to see, this one, notice the word linear is also missing from the directions. So this function is not going to be a straight line like the last two we've looked at. This is what we call, the formal name we will get to down the road is going to be a quadratic. What we want to call it right now is a parabola. So it's a parabola. And this I call your U-shaped graph. It's going to have a curved edge that is kind of rounded, kind of like the letter U. I'm trying to get it to auto draw for you. Come on, parabola. There we go. So it's going to look something like this, or it could be upside down like that. but key is your sides are now curved. So in order to get this graph, it's going to take more than 2 points. So what we need to know is how far up or how far down this goes, and we'll learn down the road this is called the vertex. And then I need to know 1 point on each side so that I know where I need to place the curvature. So that's going to take 3 points. Like always, I do start with 0. So y equals x squared minus 1 is our function. Or our line, I guess. So at 0, or x equals 0, y is going to be 0 squared minus 1. 0 squared is 0. 0 minus 1 is negative 1. So when x is 0, y is negative 1. So that's going to be 0 comma negative 1, which is here. All right, next point, do a little separation here since these are a little bit longer. All right, I'm gonna go 1 unit to the right. If you wanna go 2 units to the right, that's fine. It just kind of, it's up to you as to where you wanna go. I'm gonna go over to 1. Rather boring, I don't like to go very far. So at 1, y equals 1 squared minus 1. 1 squared is 1, and 1 minus 1 is 0. So now we get the coordinate 1 comma 0. So 1, 0. It's going to put us right here on the x-axis. All right, so I've got my 0. I have had 1 point to the right. Now I'm going to go 1 point to the left to see if I can get that U shape. So since I plugged in 1, I'm going to plug in negative 1. But you could plug in negative 2 if you want to be different. All right, so one thing you want to notice is as I am plugging these values in, every single one is getting plugged in a set of parentheses. With this one, with the negative, it is very, very crucial that you do plug it in a set of parentheses because there is a difference in writing negative 1, what we call quantity squared, versus this. So the one on the left, you're implying that that negative is being raised to the second power. So a negative 1 multiplied by itself twice is a positive 1. The one on the right, the order of operations applied here, if you go through PEMDAS, exponents come first. So what's going to happen here is that 1 gets squared first, which is 1, and then that negative is applied to it. So these two are not the same thing. So it's really important you know how to write numbers out so you don't get it calculated wrong because you didn't either write it correctly, which caused you to not type it in correctly. So this is not what we want. So I wanted the negative 1 quantity squared, which is 1, and then 1 minus 1, 0. So for this one, it's the coordinate negative 1 comma 0. And then I go plot this one, negative 1 comma 0 is here. And I've got those 3 points so I can get my U shape. So just make sure it does have a parabolic shape, meaning I can tell your edges are actually curved. Come on, auto parabola. Give it one more try. There we go. A little wonky. Oopsies. I moved it. Let's put it back. There we go. And then every graph, we get arrows. So there's arrow 1 and arrow 2. So again, you need your bottom point for your parabola, and then you need 1 point up on the left or right. Most of the time, the bottom of that graph is going to stay along 0 right now. So I always plug in 0 first. All right, next function, sketch the graph of the equation y equals, and then we have x inside a set of vertical bars. This, you got to remember, this is called your absolute value bars. Okay, so this means absolute value. And what your absolute value represents is the distance from 0. So when I can plug in an absolute value, this is when I want the absolute value of 3, I am looking for how far, so in distance is -3 from 0. Well, -3 is 3 units from 0. It just happens to be on the left, but it is still 3 units away. If I want to take the absolute value of +3, that value is also only 3 units from 0. It just happens to be on the right side. But absolute value is a distance, which means it always comes out positive. Difference between this graph versus the quadratic or the parabola is with this one, we're still going to have 3 points, but the sides here are actually straight lines. So the sides wind up making, I call this the V-shaped function because it turns into a V. And we do need our 3 points. We need that's still called a vertex. And then I need 1 point on each side so I know where to make my lines. And it could be the same thing where the V shape is pointed downward instead, but it would still require 3 points to get the graph sketched. 1, 2, 3. So just like before, I'm still going to start at 0. So y equals the absolute value of x plus 3. And then we're going to check 0 first. So at x equals 0. So plugging in 0 for x. Y is absolute value of 0 plus 3. The absolute value of 0, how far from 0 in distance is 0? Well, it's 0 away because it's on top of itself. So 0 plus 3 is 3. So our first coordinate is the ordered pair 0, 3. And 0, 3 is straight up the y-axis here. All right, next point. I'm going to go with, let's go with 2 to be different. Normally I would go with 1 and -1. Like I said, I'm boring. Let's go with 2 just to change it up. So at 2, y is the absolute value of 2 plus 3. The absolute value of 2, how far from 0 is 2? Well, it's 2 units from 0. And 2 plus 3 is 5. So this coordinate is 2, 5. So right 2 up 5, we are here. All right, next value. So I plugged in my 0, I plugged in 1 point on the right, I plugged in 2. Now I got to go to 1 point on the left, so I'm going to go plug in, let's go -2. You want to plug in -1 to be different, you can. Normally I plug in the same value, just negative. So y equals the absolute value of -2 plus 3. The absolute value of -2, I want to know how far away in distance is -2 from 0. It is 2 units away. It just happens to be on the left, but distance-wise, it is 2 units away. And then 2 plus 3 is 5. So this coordinate, -2, 5. So I go to my graph, -2, 5, yes, here. And then I look at my graph, I have that shape. Difference now with the absolute value, you make your side straight. So from that bottom point, I'm going to straight edge the right side, and I'm going to straight edge the left side. They make exact straight. So I call this the V-shaped graph. The parabola, I call the U-shaped graph. One is straight and one is curved. All right, the rest of the examples are the U-triads. Remember, the U-triads are all filled out on the completed notes. There are no videos available on those because the intention is for you to try them on your own. So you can check the completed notes if you want to make sure you've got them correct.